Hey guys, I'm going to give this a try. This is our lesson on 7.3, log functions and their graphs. I thought it better to maybe come over here at school, that way I can demonstrate how to use the calculator as well, because that's going to be some of your questions. So let's get going. I'm going to kind of skip the top part of your handout, and so I'm going to just kind of go to this little table here, but give you a little preview of what we're talking about. Logarithms. Well, before I even start talking about a logarithm, I try to connect what we've been doing. So we've been having an exponential function. You've done a lot of work with that. So I'm just going to give you an example here. 5 squared we know is 25. But a logarithm is the inverse of an exponent. Okay? And so when we think about taking an exponential equation and writing it like a logarithm, this is your basic form. Log, and then a is our base. What comes here is the number that we're taking the log of, and what we're finding is the log of something is equal to our exponent. So if I want to rewrite 5 to the second equals 25, I'm going to go log base 5 of 25 equals my exponent. Okay, so it's just a rewriting of the two. So these are equivalent to each other. And so this little table that I'm giving you is just walking us through the forms. And so this is generic. Log base a of x equals y. Okay, I like to kind of write it with the y on the right hand side. That way I kind of use arrows to draw the right direction. So if I'm doing the writing the logarithm this way, I can rewrite it as an exponential function this way. So I just go counterclockwise. A to the y, excuse me, a to the y is equal to x. All right, so here I've got log base 2 of 8 equals 3. It just wants us to rewrite it. So take your base and go counterclockwise. 2 to the third is equal to 8. So this time they gave me the exponential form of it. I'm going to go backwards and write a logarithm. So there's my base, there's my exponent, and then that's what it's equal to. So I'm taking actually the log of that. So log of my base, 1/2 of 16 equals -4. And you can check yourself. 1/2 to the -4, does that give you back 16? Okay? And so that's the format. So as I move down, I'm going to be in and out of the screen because I'm moving my paper here. What comes next is they want us to evaluate. So I'm going to slide it up. And it says without a calculator, so I'm going to do it and then I'm going to show you how to do it with a calculator, okay? So these here we can do without a calculator. So example 1, I've got log base 4 of x, and they just want me to insert 64 in place of x. So here's what number 1 would look like. Log base 4 is 64. They just want me to figure out what that's going to be, okay? And so f of x is just the answer. So I'm just going to kind of ignore it a little bit. All right. And so I'm going to rewrite this. I'm looking for the answer. So I remember I put the f of x over to the other side and made it to the right. So let's just rewrite that guy. 4 to the x is equal to 64. Well, like the very first lesson back before we were still in school, we took 64 and rewrote it as another base, base 4. So if 4 to the x is equal to 4 to the third, do you remember that if you had the same bases, they drop? so x is equal to 3. Okay, and so I do the same thing. Log base 4 of 64. Sorry. Log base 4 of 2, excuse me, still trying to get used to it. So I need to rewrite it. 4 to the x gives you 2, all right? And so 2 is really to the first power because I can take 4 and rewrite it as base 2. Isn't that 2 squared? And so if I have 2 squared, and then don't forget about your x, 2 to the first, the bases drop, 2x equals 1, x is equal to 1/2. And then the last one, log base 4 of 1 equals x. So rewrite it, 4 to the x equals 1. Well, guys, anything to this exponent equals 1. So 4 to the 0 is what x is going to be. All right? So just evaluating. Now, if you were to wanting to check your answers in a calculator, this is how you would do it. With your calculator, you're going to go to the log key right here. And you're going to hit it 3 times. So if you have a different calculator, I'm going to have to take a look at it and kind of guide you through it. So if I wanted to redo number 1, I hit this key 3 times and then I have a base that's embedded. So I can do a 4 and then type 64. And there's my answer. Same answer, okay? So that gives you an idea of how to work with the calculator. All right, let's keep going. So we've got solving a logarithm instead of evaluating one. Okay, and so I'm kind of doing the same thing. I'm going to rewrite. So if I've been given a logarithm in logarithmic form, I need to rewrite it as an exponent. So that's what they mean by this little statement here. So remember, go counterclockwise. X to the third equals 8 over 27. All right. Now, I need to just solve for x. Well, he's cubed. How do you get rid of a cube? You cube root. And what you do to one side, you got to do the other. So x is equal to, and you just take the cube root of 8, the cube root of 27. Rewrite. Now, x is in a different spot. I need to figure out, well, what does this mean? Well, anything to a rational exponent or a fraction exponent, remember the bottom number is my root that I'm going to take my number to. And then after I get that answer, I'm going to take it to the 5th power. So that's the exponent or the power. So this is like saying the square root of 4, which is 2, to the 5th power. So that gives me 32. And then example 3, I've got x in a different spot. 49 to the x is equal to the cube root of 7. Remember, counterclockwise. Well, this is like the ones I did up here on top. I'm going to take 49 and rewrite it as base 7. So isn't that 7 squared? And we'll put the x next to it. Now this looks funny, but I'm going to rewrite it as a fraction. Well, not so much a fraction, but a fractional exponent. 7 to the 1/3 power. So looky here, same base, 2x equals 1/3. Well, dividing by 2 is the same thing as multiplying by 1/2. Well, what I do to one side, I got to do the other. X is equal to 1/6. Okay? All right, flipping your page. We are now going to be talking about another type of logarithm. Okay? And so, when you see the word LOG, that means common log. Common log. And so if there's no log after or underneath as a base, that's an implied log base 10. So an easy one, log of 100 just means 10 to what power gives me 100, and that'll be a 2. Now, of course, when I have log of 5, 10 to some power has to give me back 5. Well, it'll be a decimal. All right? And so that's called a common log. All righty? But then the other type of log is a natural log. Well, instead of base 10, he is what we call base E. And remember, we ran across E when we did the PERT formula, or compounding continuously, on the last lesson. E is it's a button on your calculator. All right? And so his inverse is natural log, ln. So these are just asking you to evaluate it in your calculator. So let's just make sure you know where those buttons are. So you're just going to type in ln 15. So ln and log should be located very close to each other. So right here is the ln key, and you're just going to type in 15. And round it to 3 places. So there's your answer for that one. And then number 2, you're just going to log 37.2. Nothing to it. Okay, so that's the first examples. Now, we've got a couple of properties we need to talk about. So what happens when you have them in a certain format? So these are little properties we need to accomplish before we get going into some problems. So this is just kind of some notes to take. When I see this one, anytime I have whatever this base is, log 2, log base 2 of 1, log base 5 of 1, log base 12 of 1, log base 1/2 of 1, I'm always going to have a 0. All right, so the example over here, log base 4 of 1, is always going to be 0. Second property is if the base and your answer that you're going to get are the same. So look at my example, log base 7 of 7. You're always going to be getting the value of 1. How does that work? Well, 7 to the first power gives me back 7. So that will always be equal to 1. And then if you have equivalent equations and they have the same base, then they just drop, and then x is equal to y. They have to be equal to each other. All right. And the second part of this is just theorems of what we call inverses of logs. So notice same base here and here. A to some power has to give me a to some power. What's the power I take a to? Well, he's just equal to x. So in other words, these little guys just disappear and he comes down in front. So same thing here. These guys disappear, he comes down in front. And vice versa, now the logarithm is in the exponent. Well, guess what? They cancel, down in front. Same bases, cancel, down in front. And so this next section, you're just evaluating using your calculator. So you're just doing the natural log of all of those questions. So natural log. So you're going to type in your calculator ln 5. You're going to type in ln 77. It's embedded parentheses. ln negative 2. And then ln square root 3. And you're going to round it to, I think it says 2 places in the lesson, 2 or 3 places in the lesson. Okay? So it shouldn't be too hard for you. Just type it in. The next part, same concept as common logs, we've got natural logs. So we're going to work with these little rules real quick. These are just shortcuts. It's what I called it this page, shortcuts. So this guy right here, like the common log, e to some power. Remember, these are all base e. E to what power gives me back 1? Well, same thing we talked about earlier, 0. This one, e to what power gives me e? Well, 1. So if this is the base and I'm taking the logarithm of what the base, or natural log of what the base was, that just cancels, it just gives me 1. And then down in front, e to the x gives me e to the x. So these just disappear, he slides down. Same thing here. E, natural log base e, they cancel, disappear, he slides down. And like the common logarithm that we had a few minutes ago, if this is equivalent to that, same bases match, they drop, then x must be the same thing as y. So these are just rules. So we're going to use those rules here on the next page. So there's actually no calculator work. You're using the rules. So here we go. I want to figure out this. E to some power gives me e to the 1/3. Remember, that just drops. You get 1/3. Base e, natural log base e, gone, gives me a. This is kind of two-stepper. This is saying 15 times the natural log of 1. Well, remember, e to what power gives you 1? Well, looking back at your notes, 0. Anything to the 0 power gives you 1. So this is 0. This one, base e to what power gives you e? So this whole thing here is a 1. The numerator is a 1, then I put it over 6. And this one is e to what power gives you e to the, and this is the 8th root. So he goes on the bottom, 3 goes on the top. So what fills in the blank? 3/8. So no calculators needed. Here they just want you to evaluate it or rewrite it. I mean, you can stick it in your calculator. How am I going to not know that you don't use your calculator? But let's just show you the essence of it. 4 to some power equals 1 over 16. I can do it base 4, 4 to the x. And remember from the lesson that we did here at school, rewrite 1/16 as a power of 4, and that 4 to the negative 2. So bases drop, x equals negative 2. And then here, write it as an exponential equation. Don't solve it, don't simplify, just rewrite it. So counterclockwise. Now I think there's a little typo on this one. This guy should be up top, the way it was written. So it's 4.7. So 18 to the x equals 4.7. So you don't need to do anything with it, just rewrite it. All right. Next parts of the question, solve the equation. Use a calculator if necessary to evaluate. Well, I have a natural log question. So remember how this works. Base e to the 14.5 power equals e to the x. Well, looky there, same base, 14.5 is x. I don't have to worry about solving. And this guy here, e to the 4th equals 7x plus 1. Now, this is where you can use your calculator, e to the 4th. This is a number. Nothing can cancel here. So e to the 4th, if I type it into my calculator, find your e, caret 4, you get something like this, 54.598 equals 7x plus 1. So I'm going to solve for x, so subtract 1, get 53.598, divide by 7, x is equal to, and it says 1 decimal place, 7.7 when I quit. All right. And the last part, you are using the properties to solve. So it wants it as a fraction if you have it in lowest terms, not as a decimal. So just rewrite. 4 to the 2nd equals 7x minus 3. How am I doing that? Just counterclockwise. Then just simplify. 4 to the 2nd, 16. So solve it as normal. (32 to the 2/5 equals x. Remember a fractional exponent. This means the 5th root of 32 squared. So x is 4. And then here, I probably want to get same base. So leave the left-hand side alone. Change 64 to 4 to the 3rd. They drop. And now set the exponents equal to each other. Well, it's a logarithm, so just evaluate it. 2 to the 3rd is x, so x has to be 8. All right, last topic. You have 3 graphs on your lesson. So the easiest thing for me to kind of tell you how to do this is to just maybe make up some points. Okay, and so let me just give you the general shape of a logarithmic equation. Okay, and so I'm just going to make up a logarithm question. Log base, and this says if the base, that's the base, is greater than 1. So if I do this, log base 2 of x. All right, if I make up points, I make, remember I do it this way, that way I can go in this form. So if I say x and then y, and I want x to be 1. So this means 2 to the 1st. Sorry, 2 to what power gives me 1? Well, remember, it's always 0. 2 to what power will give me 1? Well, that has to be 0. Then I'll do a 2. So this is asking 2 to what power gives you 2? Well, he has to be a 1. And I'll do something even, like 4. So 2 to what power gives you 4? Isn't that 2? So if I were to plot those, something quick, 1, 0, 2, 1, 4, 2. You're going to notice that your logarithm does this. And he's kind of backwards. Remember our exponential function did that. And remember, in exponential functions, we always crossed at the coordinate 0, 1. If I didn't do any movement, well, guess what? These are inverses. He crosses at 1, 0. All right? And then the opposite is, what if I'm a fraction? In other words, log 1/2 of x. What would that give me as a graph? And so I just made up some points. So log 1/2, sorry, base 1/2 of 1. How do I go back and get 1? Power of 0. Log 1/2. How do I take 1/2 to the, remember 1/2 to the negative 1 power gives me 2. All right, let me give you one more. 4, -2. So if your base is between 0 and 1, a fraction, he's going to go like this. Okay, so he's going to be going downwards. So probably the easiest thing that I would suggest that you do is just make up some easy points for x. And you have a calculator, log base 2 of 1, log base 2 of 2, log base 2 of 3, and come up with numbers. Okay, and I've already done this one for you, but you can stick this into your calculator and get values, and so you can plot it. All right, so just make up values for x and make your table. So I'm just going to type log base 2 of 1. So it's right here, log, hit the third one over, base 2, and we already know the answer to that one should be 0. So you're going to plot the coordinate. Remember, this is x, okay? And so if you got 1, you're going to get your answer. So that's what you stuck in the calculator. That's what x is going to be, 0. All right? And so you're going to plot maybe 2 or 3 points. But this is the nice part. They give you options. You're just having to match up the graphs. Let me zoom out a little bit and let you see what you're seeing. Okay? Focus. So this one says, I'll do this one with you and then I'll be done. This one says log base 7 of x minus 2. So just make up some numbers. So make x be 0. You can use 0 if you want to. It may not work, but I would try, let's try 1, let's try 2, let's try 3. And so what you're doing is basically saying log base 7 of 1 minus 2, log base 7 of 2 minus 2, log base 7 of 3 minus 2. Now, what you may see is when you stick those in there, let's just tell, will it work for me? So I've got log base 7, I'm going to hit the third button over, and I'm looking at -1. Wait a minute, it gives me a domain error. That means I don't exist at 1. So looking at your options that they give you, you know you don't have anything. So this graph right here, scoot it over, is out because I don't exist at 1. All right, so I have 3 choices. So make up numbers beyond, think of your domain, 2. So go 3, 4, 5, and see what happens. So change these numbers to 3, 4, 5 if they're not coming up, and then see what you get. Okay? You can't take the log of a negative number. It's not going to work. Okay, so that's why we want to choose values beyond 2. Okay, so when I put 3, when I put 4, when I put 5 in there, now I'm good. Log base 7 of 1, log base 7 of 2, log base 7 of 3. And then you'll get answers, and then see what your points would look like, and then pick your graph. Okay, so try it, see what happens. Hit me on Remind if you need any questions, okay? I'll be happy to answer. So hopefully this helped. See ya.